All right, how's it going, everybody? Today, we're going to be going over a question from Chapter 5 of the Essentials of Investments book here. I'm going to be going over some risk and return calculations based on sort of market portfolio versus the risk-free rate allocation here, capital allocation line problem. So that's the kind of the concepts here. We're working with the Sharpe ratio, we're working with expected return, standard deviation, and overall the capital allocation line, kind of figuring out what is the ideal portfolio. So this is the question we're going to be going over here, number 12. Just some information here at the top before we start. We are given an expected rate of return of 17% and a standard deviation of 27%. We have our T-bill rate here is 7% as well. So that's also the risk-free rate. And the question number 12 gives us the information. 70% of our portfolio is invested in our fund, which is technically considered the risky portfolio. And then we have 30% of the total funds are invested in the T-bill money market fund. So A here asks us to calculate the expected return and the standard deviation of our client's portfolio. That's really, really simple to do. Let's go ahead and just go over that really quickly here. So for expected return, if you remember this from previous chapters, it's essentially just the weights, a sum of the weights times the expected return for that portfolio. So we have 70%, as it says here, 70% is in our portfolio, which is giving a return of 17%. And then we also have the 0.3 or 30% of the portfolio is invested in the risk-free assets, so the T-bills. Going to provide a 7% rate of return there. Go ahead and make the calculation if you have your calculator ready. I know last time I did them using like a calculator on my computer. That was kind of tedious, so I'm just going to do it here on my calculator. And you will get, once you do the calculations, you'll be able to see that the expected rate of return on the portfolio here is 14%. Okay, so now we have to calculate the standard deviation of the portfolio, which is even easier to do here. So we have the standard deviation times the weight in the risky portfolio. Because, if you understand for the risk-free rate, the standard deviation is going to be 0. So the proportion invested in that portfolio will have no standard deviation. So there's no need to actually do the calculations there. It'll be zeroed out. So in this case, we have our standard deviation of 27%, and that's going to be multiplied by the 70% of our portfolio that's in the risky portfolio. And when you do that calculation, you will get 18.9% for the standard deviation of the complete portfolio. 18.9%. Okay. Now we're going to do B here. So we're given some new information about the risky portfolio in itself. We have 3 stocks in there. We have stock A, we have stock B, and we have stock C. So this one's asking us, what are the investment proportions of each stock in your client's overall portfolio, including the position in T-bills? Well, we know the T-bills, wrong brush. So we know the T-bills is still going to be 30%, right? That doesn't change. It's not affected by this information. However, the 70% that was going into our risky portfolio is actually going to be broken up into some subsections. So we have A, we have B, and we have C. Keep in mind here, we have 70% of the total amount is invested in these 3 stocks. So instead of taking the whole portfolio and multiplying it by these percentages, we're actually going to just take 70% because it's only 70% of our total invested in this portfolio. So to go ahead and calculate it out, it would be 0.7 times the 27% for A, 0.7 times the 33% for B, and then 0.7 times the 40% for C. And you'll get those weights. I'm going to do the calculations really quickly. For A, we get 18.9%. For B, we get 23.1%. And for C, 28%. So the way you really check to see if you've gotten this correct here is you're going to go ahead and add up these weights here. These are the percentages invested in A, in B, and C. All of these three here should add up to 70%. So let's go ahead and just calculate that out. Just make sure that we did these calculations correct. Yep, 70%. So let's go ahead and move on to the next part here. So the next part is we're going to be figuring out the Sharpe ratio of the risky portfolio and of the client's portfolio. So the Sharpe ratio, if you don't know, it's actually commonly known as the ratio of the amount of reward per unit of risk, per unit of variability, volatility. Really doesn't matter what word you use here as long as you understand that it's risk. You're being compensated for units of risk. That's the Sharpe ratio. So for the client's portfolio or the overall portfolio, you go ahead and calculate the market risk premium. So the return on the portfolio minus the risk-free rate, and you subtract that by the standard deviation of the portfolio. Whoa. So in the case of the whole portfolio, we already calculated our return is 14%. The risk-free rate is 7%, and the standard deviation there was 18.9%. So you go ahead and make the calculation. You can see the Sharpe ratio is actually equal to 3704. It's kind of a bad 3 to redo that. So that's our Sharpe ratio. So now we're going to go ahead and calculate the Sharpe ratio for the risky portfolio instead of the overall portfolio. So for the risky portfolio, the return is 17% and the risk-free rate is 7%. And we're divided by the standard deviation of 27%. Go ahead and run the calculations through on your calculator. 17 minus 7 is 10 divided by 27 is going to be the same. It is the same as before. Now, that might not seem like a monumental idea or coincidence, but it really is. And this is the fundamental idea of the capital allocation line and the Sharpe ratio. And I'm going to show you a really, really quick diagram that's actually the answer to part B here that will really just kind of drive the point home and show you what I mean in a visual way. So let me go ahead and open up that. Oh, uh-oh. Hold on. Here it is. Okay, so here's what I'm talking about here. So we have the expected return on the y-axis. We have our standard deviation on the x-axis. These are percents, by the way. I didn't write that down. So you have the risk-free rate, 7%. You have the return on the overall portfolio of 14%, and the return on the risky portfolio, 17%, as well as the standard deviation of the overall portfolio, which is 18.9%, and you have the standard deviation of the risky portfolio, which is 27%. So the capital allocation line, or CAL, is actually literally just a line of the slope of the Sharpe ratio. And as you can see, as we showed you in those calculations, this line is constant. It starts at the risk-free rate, which is 7%, and just slopes upward at the rate of the Sharpe ratio here. So as you can see, this is a linear, it's not curved in any way. If it was changing, if the slope of the line was changing, you'd see a certain curvature to it. There's no curvature, it's a straight linear line. And it shows you that the Sharpe ratio for the client's portfolio and for the risky portfolio is actually the same. It's literally just a different allocation on this capital allocation line. So that is all for today. I just kind of wanted to introduce this concept and show you a really cool visual way. I remember when I did this problem for the first time and I drew the graph and I saw it visually. what I just solved for, it's really kind of a powerful thing, and that's why I really try to use graphs to drive these points home. So hope you guys enjoyed, and I'll see you in the next one.